Hello and Assalamualaikum to my lecturer, Madam Mahani binti Ahmad Kardri, and my fellow friends. We are from Group 6, Applied of Science Faculty. Today, me and my friends are going to present the application of differentiation, which is the topic is applied maximum and minimum problems. But first, let us introduce ourselves. Hi, my name is Alia Batrisha binti Hazman. My ID number is 2022696326.
My name is Alia Shafira Midi Roslain. My ID number is 2022886462.
Hi, my name is Nur Adlina Nadira binti Kasim and my ID number is 2022613188.
Hi, my name is Wan Nur Izzah binti Wan Ahmad Naim and my ID number is 2022467208.
Now, let's go to introduction. What is the differentiation? Differentiation is the process of finding the derivative or rate of change of a function. The purpose of the differentiation is to determine the maximum and minimum values or particular function. There are 5 applications of differentiation that we have learned during lecture. First is related rates, second is analysis of function 1, third is analysis of function 2, next applied maximum and minimum problem, lastly Ross theorem and mean value theorem. When do we apply differentiation? First, we apply differentiation when we find a trend of a quantity, whether it is increasing, decreasing, or constant. Also, we can find the velocity of the moving object. But in our topic, the derivative was used to find the maximum and minimum values of a particular function. What is applied maximum and minimum problems? The process of finding maximum or minimum values is called optimization, which involves function for which you want to find maximum or minimum values. The restrictions state or implied for such function will determine the domain from which you must work. The function, together with its domain, will suggest which technique is appropriate to use in determining a maximum or minimum value. Why do we use applied maximum and minimum problems? We are attempting to do things like increasing a company's profit, reduce expenses, or use the least amount of materials as possible to create a specific object. These are essential in the world of business.
Let's look to the problem statement. A glass window frame is in the form of rectangle at the bottom and a semicircle at the top, as shown in figure 1, has a perimeter of 4m. So there are 3 questions that will be asked. For the question 1, show that the area of the glass window is given by A equal to x minus bracket 4 plus pi over 8 bracket x power of 2. Second question is find the value of x and y that will maximize the area of the glass window. Third, hence find the maximum area of the glass window.
So it asks show that the area of the glass window is given by A equal to 2x minus bracket 4 plus pi over 8 bracket x squared. So firstly, we need to determine the parameter based on figure 1. So based on figure 1, the parameter is y plus x plus y plus 2 pi r over 2 equal to 4. 2 pi r over 2 is the parameter of the semicircle. 2 pi r is the parameter of the circle. So if it's a semicircle, we divide it by 2. So based on the parameter that we have identified, we use it to express y in terms of x. So x plus 2y plus 2 pi r over 2 equal to 4. And then x plus 2y plus pi bracket x over 2 equal to 4. How did we get x over 2? This is because based on the figure 1, r is equal to x over 2. So we substitute. So we get x plus 2y plus pi bracket x over 2 equal to 4. And then x plus 2y plus pi x over 2 equal to 4. 2y equal to 4 minus x minus pi x over 2. Furthermore, for 2y equal to 4 minus x minus pi x over 2, we multiply the numerator and denominator with 2 to let all the denominator be the same. And then we will get 2y equal to 8 over 2 minus 2x over 2 minus pi x over 2. Then 2y equal to 8 minus 2x minus pi x over 2. And lastly, we will get y equal to 8 minus 2x minus pi x over 4. After we have expressed y in terms of x, now we have to prove that a equal to 2x minus bracket 4 plus pi over 8 x squared. So based on figure 1, it can be identified that area of figure 1 is area of rectangle plus with area of semicircle. So area of rectangle is xy plus with area of semicircle, which is 1 over 2 pi r square. Area of circle is pi r square. So if it's a semicircle, then it's 1 over 2 pi r square. Then we sub y equal to 8 minus 2x minus pi x over 4 into the equation. So a equal to x bracket 8 minus 2x minus pi x over 4 plus 1 over 2 pi r square. So I have said earlier that r is equal to x over 2 is on figure 1. So we sub it. So 8x minus 2x square minus pi x square over 4 plus 1 over 2 pi. Since r square, so it's pi over 2. We square it, then we get x square over 4. So 8x minus 2x 2 minus pi x square over 4 plus 1 over 2 pi bracket x 2 over 4. Then 8x minus 2x square minus pi x square over 4 plus pi x 4 over 4 over 2. Then we will get 8x minus 2x square minus pi x square over 4 plus pi x square over 8. But for 8x minus 2x square minus pi x square over 4, we times it with 2 on its numerator and denominator to let the denominator be the same, which is 8. So it will be 16x minus 4x square minus 2 pi x square over 8 plus pi x square over 8. Then 6x minus 4x square minus pi x square over 8. Then 6x over 8 minus 4x square over 8 minus pi x square over 8. And lastly, we will get 2x minus bracket 4 plus pi over 8 x square. We'll get 2x minus 4 plus pi over 8 x square by simplify the 4x square minus pi x square over 8. Furthermore, for B, it's said that find the values of x and y that will maximize the area of the class window. So firstly, we have to find the derivatives. So the area that was given, 2x minus bracket 4 plus pi over 8x square, we expand it, then we get 2x minus 4x square over 8 minus pi x square over 8. Then equal to 2x minus 1 over 2x square minus 1 over 8 pi x square. Then we differentiate it, which we will get dA over dr equal to 2 minus x minus 1 over 2 pi x. Then let the derivative equal to 0. dA over dr equal to 0. Then 2 minus x minus 1 over 4 pi x square equal to 0. X equal to 2 1 over 4 pi x. Then we multiply 4 on both sides to expand the denominator. So we multiply 4 on x minus 2 minus 1 over 4 pi x to expand the denominator, which we will get for x minus 8 minus pi x. Then for x plus pi x equal to 8, bracket 4 plus pi, x equal to 8, x equal to 8 over 4 plus pi. Then lastly, we will get x equal to 1 over 2 m. Furthermore, we will do a second derivative test to identify whether it's a minimum value or a maximum value. So a minimum value, its second derivative value will be higher than 0. If it's a maximum value, second derivative value will be lower than 0. So dA over dr equal to 2 minus x minus 1 over 4 pi x. And then we sub x equal to 1.12, which then it will be equal to 2 minus 1.12 minus 1 over 4 pi bracket 1.12. Then equal to 0.88 minus 0.28 pi. And lastly, we will get 0.00035, which is lower than 0, which means it's a maximum value. Moreover, to find y, we need to sub x equal to 1.12 into the equation of y equal to 8 minus 2x minus pi x over 4. So y equal to 8 minus 2x minus pi x over 4. Then we sub x equal to 1.12 to 8 minus 2 bracket 1.12 minus pi 1.12 over 4. then equal to 5.76 minus pi 1.12 over 4. Then lastly, we will get y equal to 0.56m. For C, it said that hence find the maximum area of the glass window. So area maximum equal to 2x minus bracket 4 plus pi over 8x squared. Then we expand it, which equal to 2x minus 4x squared minus pi x squared over 8. And then we sub x equal to 1.12, which equal to 2 bracket 1.12 minus 4 bracket 1.12 square minus pi bracket 1.12 square over 8. And then 2.24 minus 5.0176 minus 3.94081 over 8. And lastly, we will get 1.12m square.
Conclusion. To summarize the solution, here are the steps that we use to get the answer of the question, which are: first step, find the first derivative n equals to 0. Second step, find the second derivative to identify whether it is maximum or minimum value. If second derivative is more than 0, so it is minimum value. And if second derivative is less than 0, so it is maximum value. Third step, lastly, substitute the value in the equation. In this video, we got the value of x in second derivative is 0.00033, which means less than 0. Therefore, it is maximum value. To conclude this video, we must know and understand the idea of differentiation and able to find a suitable formula or method that appropriate the question given. With such ability to solve differential questions, it is an important skill for mathematicians.